So this is our fourth lesson on exponents, and today we're going to finish our exponent laws. We're going to look at two exponent laws, and we're just going to start off with an example. So my question is, does 3 multiplied by 4 all squared equal 3 to the power of 2 multiplied by 4 to the power of 2? And why or why not? So my first suggestion is that we should use, instead of following directly with BEDMAS, where we multiply 3 times 4, let's look at just with the square. And the reason we're going to do that is because I want us to write it in expanded version using those bases, and then we're going to write it into an index notation. So we've got 3 multiplied by 4 all squared. And yes, in general we would multiply 3 by 4 and then square it, but just for our sake, just to try and get it into the other side of the equal sign, let's not do that, and let's write this as 3 multiplied by 4 multiplied by 3 multiplied by 4. So all I've done here is I've used that square, and I'm going to rewrite this so that all of my 3's are beside each other and all my 4's are beside each other. And we can do that because order of multiplication does not matter. So I can rewrite this as 3 multiplied by 3 multiplied by 4 multiplied by 4. And then I can change this into index notation and say, okay, well, I have 2 3's here, and I have 2 4's here, and I have 3 squared multiplied by 4 squared, which was my question. So the answer is yes, these are the same. And what I want us to notice here is if I have 3 multiplied by 4 squared, essentially what I can do is, because there's multiplication happening between the 3 and the 4, this 2 is affecting both this and the 3, so it affects both bases, and so I can write this out as 3 squared multiplied by 4 squared. We're going to generalize on that in a minute. So my question then becomes, what about fractions? So is this true? Is 2 divided by 5 to the 5th equal to 2 to the 5th divided by 5 to the 5th? So again, let's use this exponent and rewrite 2 to the power 5th in expanded notation. So this would be 2 over 5 multiplied by 2 over 5 multiplied by 2 over 5 multiplied by 2 over 5, and the last one here, 2 over 5. And of course I can get rid of my brackets and just rewrite this as 2 multiplied by 5 times divided by 5 multiplied by 5 times. And if I write the numerator and the denominator in index notation, what I end up with is 2 to the power of 5 over 5 to the power of 5. So in fact, our question is true as well. What I want you to notice here is what we started off with is 2 over 5 to the power of 5. All I'm really doing is saying that, okay, well, my 2 is affected by this exponent, and my 5 is being affected by this exponent, and therefore I get 2 to the power of 5 over 5 to the power of 5. This rule, it's called the power rule. Okay, so for any base a to the power of m, all to the power of n, all we have to do is, sorry, I'll use a little different color there. No, still didn't grab the yellow. There we go. We can generalize this rule as saying, well, the base to the exponent becomes m multiplied by n. Okay, and now you might be saying, well, up here when we were looking at these ones, all I did was put the 2 right beside the 3, but really don't forget that there is essentially an index notation. We can write it as 3 to the power of 1 multiplied by 4 to the power of 1, and 1 times 2 is just 2. So let's see some examples, because maybe that seems a little bit odd. So if I was asking you to simplify 2 to the power of 3 all to the power of 4. Now, if I wrote this in expanded version, well, this is going to take me a minute. You could do this. Well, it's 2 to the power of 3. 4 times. Okay, so I've just taken that fourth power there, the yellow. Oops. There we go. So we've got 4 of them, so 1, 2, 3, 4. And then I could write this in expanded version as 2 multiplied by 2 multiplied by 2. So that was the first one, the second one, the third one, and the fourth one. And if I count all these, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or if I used my shortcut, I would have said, okay, well, my rule states, we look up here, that I have my base. So my base is 2. My exponent inside is 3. And my exponent outside is 4. And 3 times 4 is 12, so I get 2 to the power of 12. And notice that with a lot less work, I get the solution right away. Okay, so let's do the same thing for the next one. Let's just do the shortcut. So we've got the base is 3, and 3 to the power of 2, and it's all to the power of 5. So all I have to do with my shortcut is write 3 is the base to the exponent 2 multiplied by 5, which is equal to 3 to the 10. Okay? Nice and easy. You just have to remember the rule. And we can expand this rule a little bit further as well and say, okay, well, if we combine everything, the b is being affected and the a is being affected, and therefore we just write it as a to the n multiplied by b to the n. Remember that this piece here is implied multiplication. So if we do some more examples of this, really there's an invisible little 1 there, so it's 4 is affecting both pieces because there's multiplication in the middle, and therefore I get 2 to the power of 4 multiplied by 3 to the power of 4. Okay, I'm going to make it a little bit more complicated now. So I've got exponents inside and an exponent outside. Oh, that was supposed to be yellow. There we go. So this 2, it's affecting the green exponent and the blue exponent. Okay, so what I end up writing is, using my shortcuts, I've got a squared multiplied by 2, and then it's multiplied by b to the power of 3 multiplied by 2. So I've just got rid of that yellow 2 outside, and this becomes a to the 4th power multiplied by b to the 6th power. Okay, now again, you could do these in expanded. It's just going to take you a really long time. Alright, what about if I have a fraction? Well, again, this 2 is affecting both pieces, everything inside the bracket, and therefore we get 2 squared over 3 squared. Okay, again, this is in index notation. I might ask you to simplify it. If you were asked to simplify fully, then you just have 4 over 9. Okay, last one. Again, this 2 is affecting the a squared and the b to the 5th. So this is a, now I'm combining these rules here, over b to the 5th times 2, and this is just equal to a to the 4th over b to the 10th. And we're done.